Thank you for joining. This is the second webinar we're doing, so hopefully this goes well. Um, this is only 30 minutes, so I'm not going to be taking any questions during the webinar. We may change that in the future, but right now, my email address is up on the screen right now. Um, you can note it now. I will also share it at the end. Feel free to send me any questions you have. I'm happy to answer questions via email. If we end a bit early, I'll give time back. Um, so what is this talk? So this talk is about how to actually make your data useful in this sort of new world of AI. Who am I? I'm the founder and CEO of Matterbeam. I have been building systems and startups around data for 25 years and plus. I've worked on storage hardware. I've worked on products, databases, machine learning, AI, analytics, all of it connecting together with a certain perspective of how to really enable data. So I have a very specific perspective on these things. So I want to start the webinar a little bit with what seems to be kind of like a paradox. AI is more powerful than ever. It's increasing in power all the time. It's more accessible than ever. Companies are desperate to use it, and they're pouring billions of dollars into AI initiatives. But there's a lot of thought out there that these projects are failing. There's a lot of ink spilled that, in many ways, a lot of these projects are failing to deliver results. There are a lot of them are stuck in sort of POCs. There was a big, much talked about paper MIT study that came out that said something like 95% of enterprise generative AI projects in 2025 failed to meet their goals. And even in that, one problem was sort of like these are new and there's like a lack of understanding and, it's trying to map AI to old workflows. But another insight that came out of that one was this notion of flawed enterprise integration, that the data plumbing and the infrastructure around it couldn't really support the use cases that were trying to be built. Um, when people talk about AI projects failing, the conversation tends to drift toward model choice or prompt design or, you know, we're using the latest frameworks or whatever. But a lot of the research that's coming out seems to indicate that the story is a little bit more boring. A huge portion of the failures seem to happen after the proof of concept. Lots of companies have proof of concepts. Many of them work. Like, I've used AI, they work. The demos look great, but then it doesn't seem to get out of POC. It doesn't scale. And the research is pointing to some common reasons. The enterprise can't integrate and use its own data in sort of a production grade reliability. Gartner put out a prediction. It's like 30% of generative AI projects will be abandoned after the proof of concept by the end of 2025. One of the explicit reasons they stated was poor data quality. These aren't projects that failed because the model couldn't do the thing. The model can do the thing. These are projects that got far enough to build a POC and then collapsed when the organization had to plug it into real workflows and real data with real constraints. Gartner had another stat that they threw out there. They predicted that through 2026, organizations would abandon 60% of AI projects that were unsupported by AI-ready data. In other words, you can have budget, you can have executives on board, you can have smart teams, but if you don't have the data in the ways that the AI needs it, the project dies before it becomes real. Some other research, Axio summarized some results from a market intelligence report, which was like a survey of 1,500 AI decision makers with, I forget the size, like fairly large employee base, like 200 plus employees. And a lot of them said they had at least one AI project in sort of proof of concept, but many of them did not have them in production. It was sort of like stuck in this pilot zone. That report claimed that companies are discovering their data isn't organized for AI. The data is, saved in different formats and disparate data sets. and it's not in a queryable form that the AI needed. So that survey, the summary of that survey was saying we needed a complete rethink of how data is stored, managed, and processed. It quantified the major blockers as data management as the top challenge, ahead of security, ahead of compute, ahead of a lot of other things, data management. Um, the limiting factor it isn't we don't know what model to use. It's we can't get the data. We can't get the internal data into the system in a usable shape with repeatability and governance. So Deloitte has also published a bunch of research on this. I won't go too far on these. They had their state of generative AI, similar things, right? The 30% or fewer AI experiments are going to make it into production. But what's the common thread, right? The common thread in a lot of this research is the POCs work. They work in the laboratory. They're usually running on handcrafted, hand curated data sets on narrow workflows, but then the outside the lab realities are different. Data changes, schemas evolve, definitions change, access rules matter. You need freshness, you need history, you need repeatability, and you need monitoring when things go off the rails, right? So companies end up in this sort of pilot purgatory. I also have this cognitive dissonance where you look on social media, you go to networking events, even in like boardrooms, everyone's like they're crushing it with AI. Everything is great. They're doing it, and it reminds me of this quote. I've dragged this quote out quite a bit by the behavioral economist Dan O'Reilly around big data. Right? It's like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they're doing it. It feels kind of familiar. So like first we hyped up big data and then ML and now generative AI. But behind closed doors, I think there's more struggle than people are admitting, and all this research is sort of pointing at that. Um, there's this often quoted and disputed stat that like data scientists spend 80% of their time cleaning and wrangling data instead of building models. Um, you know, they talk about single sources of truth, but they're, usually not single and usually not truthful. Yeah, trying to drive your AI from your real-time dashboard, it turns out it's actually batch data from yesterday, right? Like there's all these problems. We've been hoarding vast amounts of data for decades. In fact, there are other reports, I won't throw this up on the slide either, but that like 90% of data that's collected is never even analyzed. It just turns into, I forget which analyst called it dark data, coined the term. It's just sitting in storage. But when it's time to use that data for AI, it's inaccessible or it's poorly formatted or it's locked behind, months long projects to build pipelines. So if the biggest drop off happens when a POC meets enterprise data sort of reality, what is it about our data architecture that makes integration so hard? How did we get here? Um, So to understand the current state, I think it helps to sort of briefly go back in history and see how we got here. Like how did our data architecture evolve? And I contend we've essentially optimized all of our data stacks, all of our modern data stacks for business intelligence, for BI, and reporting over the past decades to the exclusion of almost everything else. And people are a little bit surprised that it doesn't fit AI needs, right? It was built for BI. So how did we evolve? First, came the data warehouses. Now we're talking about the 1980s and the 1990s. The data warehouse was designed as a single source of truth for all of your enterprise data, modeled in neat schemas for reporting. And this is great for BI. You could run consistent reports and run SQL queries, but it required a lot of thoughtful modeling and strict schema design up front. And that's how you got your sort of query performance. And usually you can only answer kind of certain classes of questions, right? Usually predefined questions, predefined classes of questions. But the whole idea was to make your data sort of tidy and centralized for analysts and ultimately dashboards. Um, then around 2010, you had big data hit in 2010, but along with it came this idea of the data lake. James Dixon coined the term in like 2010, and the original compelling promise was sort of just dump all your raw data in one place, cheap storage, no predefined schema. We had a glut of compute. We'll figure out the schema after. And you would figure out that schema and structure only when you actually needed to use the data. And this is pretty compelling. This schema on read approach was a direct reaction to the rigidity of the warehouse model. In theory, it offered infinite flexibility, right? Store everything, just dump the raw JSON, whatever, and then you decide how to use it later. And I think for a while, many of us believed this was the future, right? Hadoop and data lakes are going to change everything. I think in practice, well, we know in practice, like data lakes turned into data swamps. Without clear metadata, without governance or structure, the raw data model became a mess. Finding anything useful was a struggle. I mean, I remember the first time I experienced this at a past company. I went looking for a simple metric, and it was monthly active users at the time, in a Hadoop data lake. And I found no less than 20 different files and tables with the letters MAU or the words monthly active or monthly active user in them. And they had different numbers and they had different schemas. And it wasn't obvious which one or ones or was it multiple were used by the business. Some files were tiny, some were huge, timestamps didn't align. And then many times the people who set up or made some of these data sets were long gone. So in some ways it was like digital archaeology, it's trying to piece together the true story, right? What is this data? And reconstructing the actual truth or trust was almost impossible because many of the upstream sources and things that fed into this had, mutably changed or completely disappeared. And this is like the swamp problem. You're storing everything, but without visibility, without structure, without lineage, nothing is really usable. So you just have data without usability. So just like fashions, the 90s are back. They're cool again. We've circled back. The industry's response to the swamp problem was interesting. It was basically saying, okay, free for all data lakes, they don't work. We've got the swamp problem. Whatever. So what if we turn them into analytic databases? And this sort of gave rise to the lakehouse concept. The lakehouse is basically an attempt to combine the best of data warehouses and data lakes, sort of where it comes from is sort of sitting on cheap storage like a lake, but adding layers of tables and schemas and SQL query engines on top to act like a warehouse. So we started using table formats on blob storage, like Delta Lake and Iceberg, and enforce structure and schemas again, and schema on write. So in theory, this was supposed to give us the flexibility of a lake with the structure and queryability of a warehouse. But I think in practice, we kind of got the opposite, right? We sort of ended up with a system that kind of does both, but sort of, but poorly, but with lots of data more cheaply. We ended up recreating a one-size-fits-all analytical database on top of our lake, and unsurprisingly, it sacrificed the original promise, the flexibility that the pure data lake or whatever promised. So we traded that off for the structure and queryability. And the thing is, traditional warehouses were already exceptionally good at structured queries. These new lakehouse layers often can't match like what we could do 10 years ago on dedicated warehouse systems. Meanwhile, they also reintroduced schema rigidity and complexity and write complexity and schema on write. And now we've eliminated the sort of on-the-fly adaptability, which was, I think, the original compelling part of the first data lake idea. We lost the original promise of the data lake. So, given that sort of long history of how we got to where we're at now, what's broken? What's broken? I'll go through a few things that I think are broken in the current architecture, the way we build data systems. First is pipelines. We have pipelines on top of pipelines on top of pipelines, one for every specific need. We have data for quarterly BI reports. That's a build a pipeline. We have marketing report. That's build a pipeline. We need to create some ML features. Okay, that's another pipeline. And over years, we accumulate dozens of these. It's not uncommon to literally have 40, 50, hundreds of pipelines running, many doing similar things with slight variations. They often overlap or duplicate logic. Each is usually like a point solution to a request at a point in time. And this sort of leads to this, I mean, we've seen it in industry, this nightmare of maintenance and fragility. So, I was talking to one data engineering leader, and he described it as tightly coupled dependency hell. Every link is a narrow use case, a brittle connection that if you break, the moment that breaks, it breaks as soon as requirements change. And that's exactly it. Instead of like one robust hub feeding lots of uses, we have a lot of point-to-point, fragile, tightly coupled pipelines. So when something changes, say the source system adds a new column, or the business definitions change or are updated, half of the pipelines break. It's a full-time job and frequently like a many full-time job just to keep pipes from leaking and breaking. The worst part about this is that while nobody, after a while, nobody fully understands all the pipelines. There's this sort of fear of shutting them off because who knows which reports are being driven by which pipelines, which downstream processes would silently break. And I've lived this. I remember being like, no one touches that pipeline. No one remembers creating it, but we have to keep that running because we know at least two things will silently break in weird ways if this pipeline gets shut off. So another thing is, when people start talking about the problems with data, with AI, data quality comes up a lot. And that comes up in BI right now all the time. But what does data quality mean? Um, the traditional approach of data quality is enforcing a strict schema and cleaning data at the point of ingestion, usually, or between a bronze and a silver layer if you're like a medallion architecture. And that makes sense for sort of a data warehouse where it's meant for finance, where you don't want your numbers to be off by 5% or whatever. You don't want invalid data in your board deck that's coming to finance. But I believe this comes to a flaw. This is flawed for AI use cases. For one, it assumes we know the ways the data is going to be used in advance. So we clean it and shape it for that domain just so ahead of time. When in reality, you just see the history of the past couple of years, like AI projects are fundamentally exploratory. You often don't know what data will end up being important. Strict cleaning can inadvertently throw out valuable information. If you're collecting events from a website and an event attribute shows up occasionally, traditional cleaning paths might just discard those events. But you might later realize that that attribute was actually an indicator of something important, a new user behavior, a different code change, but it's gone. Schema on write and rigidity rules sort of can backfire because AI can actually extract meaning from oddities and outliers, not just perfectly clean data for, a finance number. In complex organizations, the other problem is that, what is truth? It's often contextual. The correct definition of a metric might differ between departments or even use cases within the same department. Um, but our data modeling often forces single definitions, and that can lead to endless debates. And sometimes the truth is in the warehouse isn't fully trusted by anyone because it doesn't match my truth. And as I mentioned earlier, our so-called single source of truth is frequently not single. AI systems which might combine data from many domains struggle with this when the data has been overly sanitized or averaged out for generic BI usage. So we also assumed that if we fixed quality upstream, it stays fixed, but data is a moving target. An AI model might be sensitive to different quality issues like subtle biases or missing edge cases that a traditional quality check might not consider. We've built tons of data tools to enforce static rules, but the AI might need to be dynamic, right? Changing those rules and changing what kind of data it needs. The old approach is sort of like if it fits the schema and it's not duplicated and it passes some checks, maybe some null checks, it's good. But that's not enough for AI. Sometimes what we need is all the messy data or all the details preserved and not pre-aggregated summaries. So the other problem right now is that we've siloed data. Our architectures are fragmented by use case. We have, systems for BI, systems for marketing, SaaS systems for these things, sometimes separate pipelines and systems for real-time streaming versus batch systems, sometimes different systems for machine learning. Each was likely added at different times for different projects. And the results is, we have these silos and integrating across them is, again, more pipelines are just painful. So, you want to combine marketing and I literally had this case where I was like, well, we have this product. What if we used marketing information about the landing pages that they came in on to shape their product experience? And people are like, oh, that's a great idea, but we can't do it. It might involve two or three data stores, pipelines moving data between them, and then there's just tons of delays and errors along the way. Uh, So another sort of problem with the silos is it fundamentally limits the time to data access. I experience this a ton. I'm sure many of you have. Like, I want to get this data for this use case, this product, this ML thing, this AI initiative. And the answer is like, okay, submit a request, and maybe that'll be a few weeks, maybe that'll be next quarter. We'll give you a pipeline with some clean data if you're lucky. In the age of AI, that's crazy. That's an eternity. If you've got to wait a quarter or two to get data to try something, like everything is shifted under your feet. And we've normalized that. People are like, yeah, it just takes time. Silos also create, yeah, sorry. So we've normalized this dysfunction. It's crazy we've accepted it. I think we need to go a different way. Like there's an entire vendor ecosystem around that thrives around tooling around this. So, what does AI ready look like? Um, the thing is, over the last few years, what AI ready looks like has changed no less than four times. I mean, like literally year and a half, 2 years. And I'm not counting ML use cases before. Like, first we had sort of simple chatbots with simple dynamic context. Having a hand curated data set that maybe you could inject parts into the prompts. That was interesting. And then we had sort of retrieval augmented generation with vector databases, RAG, and we needed different kinds of access, but then we needed that data shaped, right? We needed it chunked, we needed it vectorized, semantically chunked, ideally. Success was highly dependent on how that data was pulled, how it was prepared. Um, and then sort of under the feet, like, and originally it was the context windows were so small, we had to make these vectorized documents really small to avoid overrunning context. But then the context windows got bigger. And the space saving of chunking became less critical, even as the semantic part got even more important. So again, the way we queried it, the way we pulled the data, all shifted and changed. And more recently, we have agents, right? Agents that can use tools. And we're preparing data for access is completely different animal, right? You need different sort of rules, different ways to get the data. And now agents also want to write the data too. They want to write into our systems. What does that mean? And looking out to the horizon, I mean, I see all these signals that it could be that small language models with fine tuning are like coming at us. That's yet another way to look at and use data. Like people are they preparing for that? Building new pipelines, silos, and materializations for each of these was sort of a labor-intensive process, and using our existing infrastructure. But more importantly, as soon as we had that, the ground shifted, and what was needed was different. We can't build AI projects at BI pipeline speed, right? The experimentation needs to be faster. The techniques are moving too fast. Everything is moving too fast to wait a quarter or 2 quarters for a new pipeline to be built for data. So, how do we need to reimagine our data architecture to support AI and other fast-moving data needs and access? I'm going to outline real quickly a new perspective, one that treats data not as something that moves through rigid pipelines, but as something that's a sort of a living, reusable asset. And this perspective sort of centers on a few key principles: storing immutable facts, enable replayability, support fast materialization of new views, and modular transformations. So, key principles: immutable facts. Instead of the traditional approach of constantly overwriting data or transforming it in place or having limited snapshots, we shift to an immutable data model. That means when data comes in, um, say an event or a record or whatever, any kind of like data primitive, we store it close to as is, right? Or with some, I'll get into that a little bit. but it's a fact that occurred in time, and we don't alter that original record. This is driving towards this idea of append-only logs, event streams, change data capture, that kind of thing. These are all ways of implementing immutability. So why immutability? Why does that matter? Because the moment you start changing or deleting your past, you lose information and introduce doubt. If 6 months from now you discover a mistake in how something was calculated, or the technique completely changed and you do something different, if the raw inputs were overwritten, you're stuck. You can't get to the same state. With an immutable ledger of data, you can always trace where a value came from and you can recalculate it. And this isn't a new idea. It's been around for a long time. I mean, you can go back, like what the accounting ledger systems that have been around for, I don't know, hundreds, thousands of years. Um, you can't go back and erase old entries. You just correct things as you move forward. We want that mindset for all data, a durable journal of facts. Immutability also frees us up from upfront schema assumptions. We can store data even if we don't fully know its structure yet. If an event payload can be stored nearly raw, we can observe it and infer schemas from the data over time rather than strictly imposing it. As things evolve, you can sort of learn from it. One of our principles at Matterbeam puts it sort of like you store everything immutably and then you decide repeatedly. In other words, keep the raw truth, be prepared to interpret it in different ways. Replayability. When data is immutable and stored as facts, you gain a superpower, which is you can replay it. I sort of hovered over this. This means you can take the stored history, rerun it through various transformations at any time. Again, this is important because AI is moving incredibly fast. Techniques are not set. Experimentation is key. Being able to replay is a superpower, right? You can try the different technique. You can without disturbing the original. Um, So in traditional setups, like if things change, that would be sort of panic time. You have to find where all data lives, figure out how to do backfills, all that stuff. Maybe new pipelines, wait weeks, months, whatever. The idea of this gives it a very quick and easy way to replay data without scrambling. Um, so if you can replay data and recreate state, all those years of data you hoarded are no longer dead weight. They can be fuel for these AI initiatives. With replay, you turn historical data into living resource, like I said at the beginning, that you can rederive and reuse. It is incredibly empowering. You can get multiple teams with different views, off the same source sets. Another key principle is fast materialization. By materialization, I mean generating those specific data views or tables or index or whatever. In an AI-ready approach, we would emphasize being able to create those things really quickly and iterate them quickly. Imagine your immutable raw data is stored in some efficient format, but one that allows you to recreate other views easily. Um, so the idea is sort of collect everything in a high fidelity way, then generate fit for purpose data sets on the fly. Uh, this is like what we do with the Matterbeam architecture. We deliberately store data in an intermediate format that's not optimized for any specific query, but can be transformed very rapidly into all the different structures that might arise. Um, that's a big shift. It sounds subtle, but it's a big shift from the warehouse mindset where you optimize storage for known queries. Um, we Another key principle is modular composable transforms. Again, this is about speed, right? You want to create transforms that you can reuse to create materializations quickly. You want to build modules that are like Lego blocks, independently useful, and you can snap them together how you want. So for the modularity, what we're trying to do is optimize for flexibility. We're optimizing for parallel development, ease of change, and ultimately clarity. So I'm a little bit over time. I'm going to try and race through the last bit, which is, okay, given those key principles, what is the sort of playbook to implement this? The first I would say is stream data, don't stage it. You can always make batches out of streams. You can't make streams out of batches. You want to set up streaming data collection from your sources and store the raw data as it comes in, like I mentioned, sort of the immutable fact. So instead of waiting to batch things nightly or weekly, you and doing heavy transformations once or nightly, you try to capture the data in real time and have that source. Another playbook item I call do no harm. If you're going to clean or transform, don't change the source. Create derived views, right? Because again, like I said, you want to be able to replay and change your mind and do things differently. Um, The number of times that I was like, all right, we'll never need that field. Just dump it. Don't worry about it. And then I regretted it later. Like, ah, we needed that timestamp field or whatever. So again, this step is about ensuring the fidelity of your history. You want that complete, trustworthy ledger of facts that you can trust and replay. I mentioned modularizing transforms. You don't want the big end-to-end script. Like I literally had to work with a 20,000 line Python script that was a pipeline script. I mean, nobody wanted to dig into it because it was just a giant mess. Uh, you want on-demand outputs. Again, this is about speed, iteration speed. You want to be able to create views on demand as quickly as possible. You want to rerun as much of, use as much of what you already have, the facts, the streams, the transforms, when creating new views. You want to make that easy and painless. Um, I mentioned this again. You want to reduce iteration time. Again, exploration. You want to make this fearless, and a lot of this immutability and replayability gives you some of that. Um, and I think if you can make things clear, you want to involve and empower domain experts, right? You want to bring them in as soon as possible, people who know the data, get them into the loop, involve them in the process, make as much of the whole process visible and able to be reasoned about. And like I said, not a big 20,000 line opaque Python script. In Matterbeam, we're aiming for this sort of visual interface to make it easy to read what a view is and what its intent is and what its lineage is and things like that. So if you follow these steps, I think you can truly go from what used to be sort of multi-month data sprints or marathons to deliver data for AI in a matter of days or even hours. We've seen this with customers. The first time might take a little setup, but each subsequent use case gets faster and faster. You'll find that instead of asking, can we even get this data to do, whatever RAG model AI thing, you can be asking, well, we already have this data. Can we just vectorize it and try it over here? It's a way more fun question to ask. We have these things, let's use them. So, conclusion, in the AI world, we need to go a little bit meta. We need to really go more agile and more adaptable. AI ready, quote unquote, is a fast moving target. What does that mean? It means we need to be able to adapt to the AI's movements. And we need architectures that move at AI speed, not BI pipeline speed. And that's all I had. So sorry I went a little bit over. If you want to learn more about how we've built Matterbeam in this way, or if you have any questions, feel free to email me. And thank you so much.